Introduce Jack Didrick, a core developer who's going to talk to us about how to stop writing classes. Jack Didrick.
I don't mean to disappoint, but I'm actually going to agree with everything Raymond just said. So you've all read the Zen of Python probably many times. Couple items. Simple is better than complex. Flat is better than nested. Readability counts. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. This is written by Tim Peters. He's smarter than you are. He's smarter than I am. How many people do you know with a sorting algorithm named after them? That's the guy who wrote this. And all of these points say, don't do hard things. Do easy things. And that's what this talk is about. So don't do hard things in the first place when you can avoid it. Classes, as Raymond knows well, can be very complicated. He laid out some principles how you should figure out what you shouldn't be doing. This talk is mostly about all the places where people go wrong and how you can just not do that at all. You end up doing that anyway, even when you're trying to avoid it. So this talk is actually going to be rehashing some code, how to notice when you've gone down the wrong path, and then how to work backwards from there. This is what I tell the guys at work all the time. I hate code, and I want as little of it as possible in our product. We ship features. We do not ship code. We don't have customers because we have lots of code. We have customers because we have lots of features. So anytime you can excise code from the product, there's 4 of us, and over the last year, we've actually dropped our line count in our shipping product while shipping new features. When you make it a goal, it's possible. So if you remember one slide from this talk, it's this one. This is the biggest overuse of classes you see out in the wild. This is not a class. It looks like a class. The name is a noun. Greeting, okay, that's kind of class-like. It takes arguments and stores data in init. All right, that's kind of class-like. It has a method that uses that state to do something else. All right, that feels like a class. At the bottom, you can see it being used. It instantiates a greeting, and then it uses that greeting to do something else. This is not a class, or it shouldn't be a class. So anytime, the signature of this shouldn't be a class is that it has 2 methods, one of which is init. Anytime you see that, you should probably think, hey, maybe I just need the one method. Anytime you see this, you'll know that you should have just written a function. So anytime you start aliasing your classes to just instantiate them once, use them once, and then throw them away, in your brain you should be thinking, oh, I should refactor that. It can be simpler. Much simpler. So the other slide was with 10 lines. This does the exact same thing, and it's 2 lines. If you find that you're always passing the same argument to that function, hey, standard library has a thing for that. Functools partial, you add an argument, and then you can reuse it. I don't know how many of you have CS degrees. I have one. I learned about separation of concerns, decoupling, encapsulation, implementation hiding. I haven't used those words in 15 years since I graduated. Anytime you hear someone using those words, they're trying to pull a fast one on you. It just doesn't come up. And even if it does come up, people mean different things when they use them. It's not useful for furthering conversation. All right, so the first of the examples from out in the wild. Lots of you use third-party APIs in your day-to-day job. Anytime you have to use someone else's code, the first thing you have to do is read it. You don't know what's in there, you don't know what the quality is, you don't know if they have tests, so you just have to check it before you include it. So sometimes this can be kind of heavy. A third-party API, Muffin Mail we'll call it, shipped with one package, 22 modules, 20 classes, and 660 source lines of code. I had to read all this before we included it in the product, but it was their official API, so we were using it. Anytime they ship an update to the API, you have to diff it, because you don't know what they're doing. Maybe you sent them some upstream patches. Did they bring them back down? So 660 lines of code and 20 classes is kind of heavy, when all we do is we give them a list of email addresses and an email to send, and all we ask back is which emails bounced and which people unsubscribed. So the overuse of classes, lots of times people think they might need something later. You don't. Or you can just do it later. If it comes up, do it. So the Muffin Mail library has a module, Muffin Hash, that has 2 lines. Someone thought they were going to have to specialize a dictionary later. They didn't. But everywhere in the code is that first line. So I was reading the code, and Muffin Mail, Muffin Hash is used everywhere there might be a dict. The second 2 lines, no one in this room has to look twice at. And the fact that they're on a slide, you're like, why are these on a slide? It's because that first thing was all over the code. Some other signs that you don't need this, you have to type muffin 3 times. You're not helping anyone. You're making users angry when you have to type muffin 3 times. That's not the actual name of the company, by the way. So they fired that guy at some point, and they brought in a guy who knew what he was doing. So this is version 2 of that API, that 20-class, 660-line API. This is 15 lines. People sitting near the front have probably read through the whole thing. All it does is it uses standard library methods. It's readable. You can tell what it does. Hey, it even ships with a test suite that's 20 lines. This is the kind of thing you want. If they do another version of the API, I can read the diff in like 2 seconds. But you'll notice there's a problem. This has 2 methods, one of which is a init. And they weren't even really trying to hide it. The other method is named call. So I sent them version 3 of the API. Oop. All right. So I'll get to the other part in a sec. So this is how you end up using that thing that isn't really a class. You instantiate it, or you have long lines, or you alias it. All these things. If you ever see these things, that's when you know you shouldn't have been using a class. So this is version 3 of the API that I sent them. It takes up 0 modules in our code base because I just put it at the top of the module that I was going to use it in. This does everything that their 15-line API did, which does everything that their 660-line API did. This is infinitely readable. It just uses standard library parts, and it works. So we started out with 1 package, 20 modules, got it down to 1 module, and eventually 0 modules. Started out with 20 classes, went down to 1 class, realized that that wasn't really a class, and now we have 0. 130 methods in that original thing, down to 2 methods, down to 1 function. 660 lines, 15 lines, 5 lines. It's easier to use, it's easier to write. No one has to wonder what's going on. So, to echo what Raymond said, namespaces are not for creating taxonomies. If you come from Java, you probably think they are. Namespaces are for preventing name collisions. If you have a deep hierarchy, you're not doing anyone any favors. The Muffin Mail, Muffin Hash is just extra things for people to remember and type. The standard library has very flat namespace because you either remember what the module is called or you have to look it up. It doesn't help if you have to look up the package that it's in, the package that it's in, the package that it's in, and the module name. You just want to know the module name. So, embarrassingly, this one is from our own code base. And you can see some of the same sins in here. Services crawler, crawler exceptions, article not found exception. Besides the two-method class, one of which is init, exceptions are overused. That's anytime you type class, you should be thinking about what am I doing this for? So this was a package with a module that had 2 lines in it, which was an exception. You have to type crawler twice to use it and exception twice to use it. The name itself, article not found exception, is repeating itself. It's unnecessary. So when you're naming exceptions, you can call it empty beer, beer error, beer not found, but beer not found error is excessive. You can just use standard library exceptions. People understand them. Unless you want to catch a very specific condition, lookup error is just as good as anything else. You know, if you get an email with a traceback in it, you're going to have to go read it anyway, and it doesn't really matter what the exception was named. Another reason you don't have to complicate the names of your exceptions is because anyone who's reading the code sees that the thing right after either a raise or an except, it's got to be an exception. So adding the word exception to the name of the class doesn't help. Python standard library, it's got some rusty corners, but it's a pretty good example of how you should do things. 200,000 source lines of code, 200 top-level modules, averages 10 files per package. And that's only because there's a couple third-party projects that were added to the standard library that were already packages that have like 2 files in them. It only defines 165 exceptions and 200,000 lines of code. So once again, anytime you think you need to write an exception, you probably don't, because the Python standard library gets along quite fine with just 165. So I'm not totally anti-class. Classes are great for things that classes are great for. So yes, when you have a bundle of mutable data and a bunch of related functions that you want to use with that data, then yes, classes are the right thing to do. You don't have to do this much in your day-to-day, because if you're pulling something from the standard library, someone else has already done it for you. There is one case in the standard library where this isn't true, which is the heap queue module. So a heap is just basically an array that always stays sorted. And there's about 10 methods in the heap queue module, and they all act on the same heap. So their first argument is always the same. If there's a second argument, it may differ, but they're always operating on the same thing, which kind of implies, yes, this actually is a class. Every time I actually need to use a heap, I end up implementing this. I keep it in my toolkit. It's all those functions plus a little helper, which is the key, similar to sort. So when you're adding things to a heap, you're doing an A star and you're trying to score how close is this thing for pathfinding. The key is your scoring function. So anytime you push something onto the heap, you run the score. Anytime you pop something off the heap, you throw it away. Danny Greenfield is going to be doing an OAuth Open Space Summit. The state of OAuth in Python is rusty. So again, with the using third-party libraries, before you use them and import them and use them in your code base, you have to go and read them. I was trying to use the Google URL shortener. I just wanted to take URLs and make them small. So there's one massive project that Google exports. It's 10,000 source lines of code. 115 modules, 207 classes. I did a rant on this on G+, which almost no one saw, and Guido said I decline any responsibility for Google API code. In 10,000 lines, there's bound to be some stinkers. Like the muffin hash, there's a class called flow, which is subclassed by other classes. It's pass. But it gets its own module, and anytime you're reading any class that derives from that, you have to go back and check and assure yourself that it is indeed an empty class. So someone thinking towards the future said, I can write 3 lines of code now so I don't have to change 3 lines of code in the future, and cost everyone who's reading the library some time. Similarly, there's a class called storage, which doesn't do much. It almost does the right thing with raising errors. It reuses a standard library error, but it aliases it. So you, again, have to go out and read their code to figure out what it's actually doing. So I spent a week doing OAuth 2 stuff. It took a couple days to read through that 10,000 lines of code. So then I went and looked for other libraries. There's Python OAuth 2. It's the second version of Python OAuth. It doesn't actually do Python OAuth 2. But that took a while to figure out. So that one was a little bit better. It's only 540 lines of code, 15 classes. But I wasn't going to put that in either because it didn't actually do what I needed to do. So I rewrote that to just do bearer token OAuth. It's Python FOAuth, or if you prefer, FOAuth. and it's just 135 lines of code, 3 classes, because I didn't refactor enough. One of them is class error exception pass. It's an embarrassment. Finally, most of you have seen Conway's Game of Life. You recognize it even if you don't know it by name. You have a grid that has cells in it, and each turn you count the number of cells that are nearby, and depending on the number of neighbors you have, you either turn on or turn off. And you can end up with cool patterns like this. The glider, the cells in front are coming alive just as the cells in the back are dying. So you get this thing running across the grid. We asked this in interviews as a kind of fizz-buzz question, because it's just a couple rules and a board. So if you can't do this, we don't really want to talk to you. Cells are a noun. So most people, first thing off, they say cell's a noun. I'm going to make a class. And what are the properties of a class? Well, it has a position. It's either alive or it's not. It's going to have a different state next time, maybe. And what else? Oh, it has neighbors. And then they get around to defining the board. They say, well, a board's just a bunch of cells. You know, it's a grid. And so it's a bunch of cells, and then every turn you click it, and it turns into a next thing. And it's at this point where you should say, hey, I have a class that has 2 methods, one of which is init. And the only thing it has is dictionary, so I should just use a dictionary. And then since you're using a dictionary, you're like, well, I don't really need to keep track of the positions of the cell, because those are in the dictionary. And alive is just a Boolean, so instead I can say, is it in the dictionary or is it not in the dictionary? So I don't need that one either. And then you say, well, I don't really need a next state. I can just create a new dictionary. So then you end up with Conway's really simple game of life. This is your neighbors. Does almost nothing, but very succinctly. And this is an entire implementation of Conway's Game of Life. That's it. So you don't need 2 classes. Instead of a dictionary, we're using a set, because we don't really care about the values, if they're either in there or not. And it just recalcs the board. The bottom is the coordinates for the glider you saw earlier, and you pass it in, and the glider goes around. And That's the whole thing. That's all you need to implement Conway's Game of Life. So in conclusion, if you see a class with two methods in it, it's not a class. Don't make new exceptions when you don't need to, and you don't need to. and refactor relentlessly. And that's it. Anyone? Mr. Hedinger.
What do you think the social forces are that drive people to write the kind of muffin-style code that you saw?
It's people who... I'm sorry. What causes people to do things like the muffin hash? To immediately think that, I might need this later. I don't know. It's ex-Java people. It's what they teach in CS curriculum. It took years to beat it out of me. That's all. Yes, it's a form of premature optimization.
Test. One of the problems I've run into when library providers use func_tools or these closures, like you suggested, for some of these parameters, like in your greet method, that greeting is no longer accessible. So as a user of that library, I can't introspect that greeting. I can call greet as many times as I want, but I can never know what the greeting is going to be. And that's where I find value in there being a class. So I see what you're saying in terms of if you have control of the code, you're writing your application, make it as simple as possible. But as a library writer, I want to expose a little bit more information. What would you say to that?
The question was, using func_tools partial in particular, you can't get at what was passed in, what was curried. The answer is you can, but it's a dunder and not documented. I wrote it, so. So yeah, there's a danger that you can oversimplify or do this too much. Anyone else? Mike?
Yeah, I want to pick the point with you about the class you showed, which declares an empty dict. It was float class, and then everything else subclasses from that. So, is your point that this should never have been written, or that after it was written, it should became obviously unnecessary? It should have been refactored out, because you talked about implementation hiding earlier. So, okay, this is not the empty dict one. I'm talking about the empty dict one. So the one with the empty dict, they might have come back later on and said, make it a named tuple, or make it an ordered dict, or it must be a dict such that we can iterate over it deterministically, or it must be a dict with a random method. So, those are all legitimate reasons for declaring a base class. And
yes.
If sometime later on you find out, oh shit, it wasn't necessary, are you saying it should have been refactored out?
Well, there's two things. One, you shouldn't have planned for the future like that in the first place, preferably. But if you think you had really good reasons for it, and then you notice later that they weren't good reasons, you can go back and refactor it out. So anytime you write class and then pass on the next line, you should really look into your soul and figure out where you're going.
No, sure, but let's give them the presumption of sanity that they didn't just write a blank class with pass. They iterated a few times, and they had rational reasons why they thought it was going to be non-empty. And later on, maybe the API was too set in concrete, and there are sort of social reasons why they weren't able to refactor it. So I think your criticism is more of the design process. It's not of the guy that wrote the 3 lines of code.
So the question was, they might have had good reason, and they might have.
Well, I'm saying you're assuming they were in charge. They were total owners of the design process, and they didn't have people pushing back and saying, "No, you've written the API. You can't refactor it."
Yeah, I mean that's a process thing. It may be true.
So I've actually done a little bit of work where we would reuse the built-in exceptions. The two big ones are always key error and attribute error. And one of the things I found is that sometimes you end up actually catching an error that wasn't the one you intended to, which is the time you'd make your own error class, right? I just wanted to point out that what we've been doing a lot is subclassing the built-in Python types, so that way you can still catch your error, but everything else that expects it knows what to look like. The other thing is, when you mentioned with the classes, just use a dict. We do have a few times when you've got when you have a lot of data and you've got maybe like 10,000, 20,000 dicts, and you're trying to find out where your memory leak is, or you're getting an exception because some data is going somewhere that you don't expect it. It's helpful to be able to tell what you're looking at. In other words, like a dict with 5 things that have numbers in it, not all that useful. So, I mean, that was one of my comments, but would you say that, as far as, as the question, is subclassing the built-in exceptions still overkill, or is that more acceptable?
So the question was, is it okay to subclass built-in exceptions?
Yeah.
And
yeah, from the angle that sometimes you might, if you just catch all key errors, you're going to catch errors you don't intend to catch.
right. And in general, can you add information to things? Even if you're going to use them just the same as the built-ins, can you give them a name?
Yeah, does that fit with your philosophy, or is that still overkill?
For exceptions, I don't use custom exceptions until I need to.
Okay.
So it might be tough in the case where you're raising an attribute error, they're raising an attribute error, and it takes you a while to figure it out. So define your own exceptions only when you have to.
One last question.
My question is, I've seen a lot of the pattern of classes as mere containers for constants. They don't actually do anything, they just hold a bunch of constants. How do you feel about those?
So it's sometimes useful to use classes as tiny namespaces when you don't want to add a module and you just need like 4 lines. It's even useful to hold functions in. In Python 3, unbound methods go away. In 20 years, no one ever found a practical use for them. So now when you pull a function out of a class, as opposed to, say, an instance, when you pull a function out of a class, you just get the function. So if you want a small namespace with some constants in it and maybe a small bag of functions, then classes are fine.
Okay.
All right. Thank you.